Here in 14.5, we have the idea of operator overloading, and this is really where the session overview foreshadowing of buckle up stuff is going to get weird. This is where it gets weird. So let's just put those two terms together and define them and try to move on from there. Operator, so we know what operators we have in C++. This would be things like plus, minus, divide. This would be things like the in operator and the out operator. This would be things like plus equals. This would be things like what does it mean when we have square brackets for an array. You can see the entire list here on page 845 of operators that you can overload. So overloading, you'll recall from 13b in last session, you'll recall that means what we're going to do is we're going to augment the functionality of something that already exists. And that is what we are doing here with overloading these operators. Now, the examples we have here, like I mentioned again in the overview, and like I mentioned in 14.3 and 14.4, are going to become more and more abstract. And that's because it's just where we are in the the overall development for C++. We have run out of well-trod road, and here we go into the woods. So let me give you an example that sort of follows something that we have been doing, but we're going to change the functionality that we have. Now, here in 14.5, I'm going to let you go ahead and look at exactly how this is done. And what I want you to do is read it over, get a sense for why is happening, and later on in the how is happening portion, we're going to look at this again in the code sample section. But what I want to get accomplished here is just talk about why we would do something like this. So let's look again at the idea of a student class. Now, why would I want to be able to add students together, right? It doesn't make any sense that if I have a student class and if I have instances of that student class, student 1, student 2, student 3, student 4, student 5. I can't really take student 1 plus student 5 and equal student 6, right? That's not math. That's lunacy. And however, maybe there's a good reason that you want to add students together. What happens if we had another class, a group class? And what happens if a group class consisted of an array of student objects? Now, what we could do in the group class is overload the plus operator. And what we can do is say, so long as we have instances of the student class that are already instantiated, that already have values in them, what I can do is add them together to create a group. So what I could do is say group 1 equals student 1 plus student 2 plus student 3 plus student 4 plus student 5. And what we're not really doing is adding them together. We're creating a functionality that did not exist for the plus operator before. What we're saying is when we use the plus operator now, when it's in reference to student objects and when it has a group class associated with it, what I'm doing is taking those objects, I am putting them in an array, and I am associating them as one instance of the group class. So that's how we might overload an operator. In this case, it's a math operator, the plus. Equals, we can do the same thing. We can say overload the equals operator so that one array of objects can be essentially copied into another array of objects for their values, just like we saw in 14.2 or 14.3 and 14.4, just with more and better functionality. So again, the examples that you see here in the text, I'll tell you, I really think it's a slimy thing with the idea of feet. So when you inches in a foot, so when you add another foot, you're changing the math to do something, and it's literally called weird here in 14.5. And quite frankly, you don't have to go that deep into Never Never Land to find good use of overloading operators. It's when we want to change what an operator does based on the overall schema of what our program should do. So if I can add students together to create a group, I'm not doing mathematical plus. I am adding in a way that makes some sense, but isn't really traditionally supported in the way that C++ functions. So again, we are coming back to this in the code samples at the end of the chapter.